So let's look at number 2. So now we know that for this is the rate, the expression, rate law expression, okay? Because we know that order of reaction for NO2 is second order, so you can see it is second order, whereas the rate of reaction for, the order of reaction for CO is 0, okay? Okay, write down the rate expression for the reaction. So kita dah buat lah. This is the final rate expression ataupun rate law expression. Ia benda yang sama ya. So rate law expression. This is rate law expression. How will the reaction change if the NO2 concentration is half? So kita masuk kita lah. Rate drops to 1/4 from the original value, because if you look at, this is the rate law expression. Okay, sekarang ni kalau concentration NO2 is half, separuh, so you can see because it is with the power of 2, so the rate is actually 1/4. Dia akan dia jadi 1/4 lah, sebab 2/2. Rate akan turun 1/4 daripada yang asal ni. Okay, if you have any question, just stop me ya. 2/2 1/4 lah a new rate R, katalah R1 so it's 1/4 K NO2. NO2 ni yang baru lah, because it's kuasa 2 dah. Alright, now next question. The bromination of acetone is acid catalyzed. So bromination, acetone dah ada dalam soalan, acetone. And then you have bromine, okay, acid catalyzed, and then you have brominated. Saya pun tak tahu apa nama chemical dia. Plus H plus Br minus. The rate of disappearance of bromine was measured for several different initial concentration of acetone, bromine, and H plus. So diberi dalam jadual concentration of all the reactants, okay, at different time lah. Okay, deduce the rate expression for reaction and give the order with respect to each reactant as well as the overall order. So you need to find the reaction order for each reactant ya. Kena buat lah ya. First kita tulis dulu dia punya reaction order ya. So ini kita tengok, so that yang general dia R equal to K with all the reactants lah ya. Semua ada, cuma salah ni, salah. The rate of disappearance of bromine was measured for several. Okay, sorry R equal to K CH3 CO CH3 acetone. Kita tak tahu dia punya reaction order, and then bromine ya. Di atas ni salah, ni produk. Okay. Alright. Deduce the rate. Sekarang ni kita nak guna yang ni ya. Oh tapi sebab okay. Faham. Kenapa saya buat macam tu? Kenapa H plus masuk? Oh, I see. Because it is acid catalyzed. Okay. Alright. Tengok jawapan itu. Okay. So H plus ialah Z ya. Nampak H plus ialah Z. Got it. Sebab dia acid catalyzed ya. So kita cuba selesaikan satu-satu, tapi sebenarnya kalau kita tengok dekat bromin tu, okay, bromin tu obviously kalau kita tengok dia tak ada, kalau tengok jadual dia, semua orang tengok jadual tu, bromin tu pun walaupun kita increase ya, cuba tengok jadual yang acetone 0.3, line pertama, row pertama 0.3, kemudian row kedua acetone 0.3, H plus 0.05, row kedua pun H plus 0.05 ya. So bromin saja, if you see that bromin only being increased ya, daripada 0.05 ke 0.1. Hopefully semua orang nampak lah jadual ni ya. Kalau tak macam mana nak follow. So it is obvious, initial rate dia pun masih sama. Maknanya bromin ni memang Y is actually 0 eh. Kita tak perlu nak kira lah sekarang sebab kita ada 3. Okay, so directly kenapa H plus ada kat sini? Sebab kalau kita tengok reaction asal dia, acetone campur bromin Br2, acid catalyzed. So dia acid ni dia ada contribute H plus lah. Okay, so that's why jangan takut sangat lah sebab dalam jadual dah diberikan. Okay, ada 3 reaktan yang terlibat lah. So that's why you need to put H plus. So this is the final, betul lah. Final ni saya nak tunjukkan macam mana nak dapat lah. Kemudian kita teruskan. So now kita just cancel out yang bromin, tak perlu fikir lah. So when you need to calculate the X and Z, Z. Okay, kita kena retain one of the concentration. Contohnya kalau kita tengok row kedua dan ketiga, kepekatan acetone 0.3 dan row ketiga pun 0.3 kan. So di situ kita tengok H plus, concentration H plus 0.05 and the row 3 is 0.1. Okay, so means that the concentration of H plus change, but the concentration of acetone is retained. Yeah. So you can use that. You can use that, and we can use the initial rate tadi. So let's put this. So anyone does not understand how I get this one? Semua tahu?
Yang ni macam dia compare individual lah kan? Macam dia compare row 1 dengan row 3. Lepas tu nanti kena buat lagi ke untuk yang lain tu?
Tak payah. Because we just want to have the order of reaction. Once we identify the order of reaction for H plus, yang ni kita H plus lah kan. Sebab H plus is the one that has different concentration kan. Yang ni adalah concentration H plus. We do not need to do different concentration dah. Once you have identified H plus. Okay. Kita tak boleh ambil row 3 and row 4 sebab concentration of acetone is different. Okay. Kan? Row 3 for H plus and row 4 actually different kan? But we cannot take it because acetone is 0.3 and 0.4. So dia tak boleh. Dia mesti satu fix, satu berbeza. So yang ni clear?
Ya, Prof.
Alright. Yang ni sebenarnya kita dah bincang sikit lah. Okay, now. Yeah.
Saya nak tanya kenapa yang Y equal to 0 tadi tu, yang bromin tu? Saya tak faham.
Bromin tu kena tengok jadual tu balik. Okay. Boleh nampak jadual tu? Okay. So first row untuk bromin 0.05 kan? Boleh nampak?
Boleh.
Okay. Second row 0.1 ya. Betul? Tapi acetone and then H plus is fixed. Betul? Kepekatan dia sama kan?
Betul.
Right. So kita tengok pula initial rate dia. Sebelah kanan sekali. Sama tak?
Sama.
That's why meaning that bromine does not affect the rate of reaction. So automatically dia punya reaction order for bromine is 0. Dia tak affect pun rate of reaction. Okay?
Faham, Prof. Terima kasih.
Right. So kita teruskan. Sekarang ni kita nak dapatkan X pula kan? So X, we need to vary the concentration of acetone. So kita kata, let's say we take alright, row 3 0.3 dengan row 5. Kenapa kita ambil tu? Row 3, betul. Tak boleh. Row dia kena mesti sama. Betul lah. Row 3 dengan row salah. Row 2, okay. Acetone row 2, kita tengok H plus 0.05 kan. So kita kena cari H plus yang 0.05 juga. Okay. So kita kena ambil row 2, acetone 0.3, H plus 0.05 dengan row 5. Row 5, concentration of acetone 0.4. Fahamnya bila saya sebut row tu, betul lah row kan, bukan kolom. Baris yang kelima, 0.4, kepekatan acetone, and then concentration of H plus sama, 0.05. Jadi kita kena ambil initial rate yang row yang betul. So row yang row kedua 5.7 darab 10 kuasa negatif 5. Okay. Dan kita ambil row yang kelima. 7.6 darab 10 kuasa negatif 5. Okay, yang ni faham ya? Okay. Alright. So now you just have to solve X. So kita akan dapatlah. Tadi Z kita dah tahu equal to 1. And then bila kita solve X pun kita dapat dia equal to 1 ya. Kalau selesaikanlah, you all selesaikan. So now kita dah ada the next expression. Okay, belum selesai lagi sebab K tak kira lagi. So cara nak kira K, masukkan mana-mana value lah. Masukkan mana-mana value initial rate tu. Ya. Maknanya kita ambil kepekatan, let's say kita nak guna row 1 ya, maklumat daripada row 1 ya. 0.3 acetone, 0.05 H plus. Okay. Rate kita ambil 5.7 darab 10 kuasa negatif 5 katakan. So kita boleh kira K. Yang ni saya ambil value apa saya pun tak tahu. Tapi you all boleh ambil je mana-mana value sebab kita dah ada expression ni tadi, kita dah tahu reaction order, kita dah tahu dah yang ni. Jadi kita masukkan nilai R, nilai concentration acetone dan nilai concentration H plus. Ya. Tapi mesti row yang sama lah, tak boleh lah ambil initial rate lain, concentration lain. Ya. So mesti masuk row yang sama. So that once you put all the necessary information, you will get the K value. So once you get the K value, okay. Ini dah soalan lain ke? Ini saya tunjuk je lah. Ini saya tunjuk contoh value yang saya ambil lah. 0.05 H plus. Maknanya saya ambil row. Mana saya ambil ni? Oh bukan, ni soalan B. Okay, B dah siap. B dah siap kira, ya. K, what is the numerical value of K, the rate constant. Okay, kita dah siap kira. And then C, if H plus is maintained at, ada soalan tak yang tadi macam mana dapat K? Okay kan? Okay, so C, if H plus is maintained, concentration is of H plus is maintained at 0.05 molar, whereas both acetone and bromine are 0.1. What is the initial rate of the reaction? Okay, so sekarang ni kita dah tahu this is the expression kan? This is the rate law expression. Nilai K pun kita dah tahu yang tadi sebab nilai K tak berubah. Sekarang dia nak minta kira berapa R sebab initial rate is R. So given the concentration H plus 0.05, acetone dan bromine 0.1, diberi dalam C. Tapi kita tahu bromine will not affect the reaction. So kita tak perlu kira lah, tak perlu masukkan concentration bromine dalam rate law expression ni. So kita masukkan maklumat yang ada ialah acetone 0.1, H plus 0.05, nilai K kita dah kira tadi yang soalan B. So kita boleh kira R. So this is the new rate was with given concentration. Okay, okay ya. Okay, kalau ada soalan stopkan saya. So number 4, molecules of butadiene C4H6 can couple to form C8H12. Okay, the rate expression for the reaction. Okay, rate expression is given rate equal to K, concentration of C4H6 with reaction order 2. Okay. And the rate constant is estimated. So K pun dah ada. Estimated to be 0.014 liter mole negative 1 second negative 1. If the initial concentration of C4H6 is 0.016, how much time in second must elapse for the concentration to drop 0.01 molar, 0.016 molar. So dia kata this is the initial, the initial concentration of C4H6. Dia tanya berapa masa dia, when that the concentration of C4H6 will reduce to 0.016 molar. Okay. Okay. Sekarang ni okay, this is rate law equation, rate law expression, but in integrated form. Kan kita dah belajar kan, rate law expression in integrated form for zero order, first order and second order. Okay, so dalam soalan ni kita dah tahu dia second order, betul kan? Sebab order of reaction tu 2. So kita kena guna the rate law for second order. Janganlah guna first order punya ke zero order punya. Because we already know the integrated form of the reaction law rate law expression for second order. So what we can do is to just put in all the informations. K dah ada, given to you. K is given. And then the initial concentration is also given. Okay, initial. And you are to okay, and you also given final concentration. Okay, because the concentration drops to 0.0016 molar. So from there, what you need to calculate is the T value. Time taken for the concentration of A initial to go down to 0.016 molar. Okay, it's just that you must know, you must know which equation, which equation that you need to use to be able to calculate the T ke. Kadang-kadang mungkin dia bagi T tapi suruh calculate final concentration ke, okay? You must know which rate law expression, rate law equation, whether it is for order of 1, 2, or 0. Okay. So rate law equation tu kena hafal dalam final memang tak boleh diberi all the if you remember test 1 I have given all the equation. Test 2 saja saya try lah tak bagi. Final memang tak boleh diberi, so you have to memorize all the equations. So kita tengok nombor 5. For the hypothetical reaction, maknanya apa tu? Okay, saya rasa kita skip yang ni. So tiba-tiba dia masuk exothermic, endothermic pula. Okay. Saya rasa dah. Sekejap verify the data for the reaction given. Verify the data for the reaction given. Ini ada nombor 1. Okay, ini soalan lain ni. Okay, verify. Okay, ini kita refer soalan nombor 6 Soalan nombor 6 tak silap saya jawapan ni. Okay, verify that data for the reaction given above obey the Arrhenius equation. Okay, and find the activation energy for the reaction. The bond dissociation energy for oxygen is 492. Ni bukan soalan ni lah kot. Comment on the magnitude of your calculated activation energy. Where does betul. Where does the extra energy to break the O2 bond come from? Okay, so for Arrhenius equation, you have to, saya tak tulis penuh lah di sini Arrhenius equation, but from the Arrhenius equation, you can plot the graph. Ln K, because it's given in the table. It is given in the table, a value of K, and then the T, temperature value. So if you refer back to your slide, the Arrhenius equation, so you can plot ln K versus 1 over T. Okay, daripada data tadi you boleh plot the graph ln K versus 1 over T, and from that plot you can obtain the slope ratio. The slope ratio yang ni, okay. So awak akan dapat ni lah value, ini R the slope is negative 49.6 the power of 10 to the power of 3 times R. Itu nilai slope dia. So you have to look at the Arrhenius equation, and then from there, okay, so you can calculate EA. Ini pun kena tengok Arrhenius equation. EA is actually saya tak buka, saya tak ingat Arrhenius equation, but you can have this EA from this calculation. R ni adalah constant ya, jangan lupa ya. R ni adalah gas constant. So maknanya boleh darab je lah. Boleh cari je lah gas constant. But make sure you have the right gas constant. Gas constant ada dua, 8.314 yang dalam unit joule. And then satu lagi 0.0082 atmosphere over moles, Kelvin something. So you have to use the right R. So buka balik please have a look at the Arrhenius equation untuk faham soalan ni. Okay, kena plot graph lah. Okay, number 7 I have given in a video form number 7 I have given in a video form how to identify rate law expression using reaction mechanism. Yang tu saya dah, so I hope that you have studied how to use rate law, how to identify rate law expression by using reaction mechanism. Okay, number 7. So right. So number 8 tak payah jawab lah. Okay. Sekarang ni buka pula tutorial kinetic yang satu lagi. Yang scan version tu. Okay. Dah? Right. So sama je lah. Express the rate of reaction in terms of rate of change of each reactant and each product in the following. So similar to what we have discussed in the tutorial just now. So tak susah lah as long as you understand how to write in a differential form. Alright, use times expressed in second, okay, to give the units of rate constant for reaction. So first order, this one you can do by yourself lah. You just have to put in the value if it is okay. First order, so the unit is just molar. So in the end you get this. And then let's say for second order, if this yang ni molar kuasa 2 lah. So you have the final unit. It's just maths lah. Saya pun tak nak lah teruskan. You have to do by yourself. Ini simple je. Now, alright. Number 3 Number 3, rate data were collected for the following reaction at a particular temperature. Okay, so you have ClO2 plus hydroxide producing chlorate, I think. Okay, chlorate ke. Alright, so what is the rate law expression for this reaction? So sama juga macam steps tadi. So now you identify the reactant. The reactant is ClO2, okay, and 2 hydroxide. This is the reactant kan? So the reactant, so this is the general. So this is the general expression. So we need to identify what is X, what is Y. Means that the order of reaction for ClO2 and order of reaction for hydroxide, OH minus. So same steps, same steps. Kita kena tengok one by one. Okay. Row experiment 1 and 2. Okay, so experiment 1 and 2, we'll see that the concentration of CI ke CL? CiO2 is changed from 0.012 to 0.024. Betul lah? Whereas concentration of hydroxide is fixed. 0.012, experiment 2 0.012. So kita nak yang tu lah sebab kita nak cari dulu order of reaction for CiO2. Cl ke Ci? I kan? So tak apalah, okay. So kita masukkan value dia 0.012 concentration pertama, 0.024 concentration yang kedua, and then the initial rate, experiment 1, 2.07 times 10 to minus 4, and then the rate for experiment 2, 8.28 times 10 to minus 4. Okay, yang ini just mathematical operation that you have to do. So you get final value kalau dah kira X equal to 2. So means that the order of reaction for CiO2 is 2. Now next one, we need to find out about Y. Okay, Y ni untuk OH minus pula. So from OH minus, we can see that experiment 2, okay, experiment 1 and 3. Okay, experiment 1 and 3 is suitable. Why? Because the concentration of CiO2 is similar. Okay, kita kena tetapkan satu varies. So experiment 1 0.012 untuk CiO2, experiment 3 0.012 for CiO2. So dia sesuai lah. So experiment 1 concentration of OH minus 0.012, experiment 3 concentration of OH minus 0.024. So rate of reaction for experiment 1, this one 2.07, experiment 3 4.14. So if you solve it, Y should be 1. Ini kenapa 3 pula ni? Okay, sorry, yang ni jawapan yang ni. Okay, so the overall, so now the overall reaction is actually 3, tapi kita bukan nak cari overall reaction lah. Kita nak tulis the rate law expression. Okay, so now the rate law expression, saya tak tulis ke? So you can write now the rate law expression. Rate is equal to K. Okay, what is the rate law expression? The order with respect to each. Okay. CiO2 is 2. Okay. OH minus is 1. Okay. So you have to use the same steps just like the tutorial just now. You have to find the value of K. Baru lengkap. Kalau tak lengkap dia punya rate law expression. How to find K? Macam tadi lah. You ambil any value from experiment 1 ke experiment 2 ke. This time you do not have to worry. Ambil je. Kalau nak ambil experiment 1 means that you have to take concentration of CiO2 from experiment 1, OH minus from experiment 1, as well as the initial rate R tadi dalam experiment 1. And then you can calculate K. Okay, Alright, describe the order of reaction ni, just bagi tahu je lah. Order of reaction for CiO2 is 2. Order of reaction for OH minus is 1. Macam tu lah je lah. Okay, what is meant by the half-life of reactant? Ini refer balik lah pada tutorial, pada nota. Okay, what is the meaning of half-life? So number 5, okay, number 5, the rate constant for decomposition of nitrogen dioxide, okay, with a laser, blah blah, with a laser beam. Decomposition means that NO2 is decomposed with a laser beam. So the rate constant maknanya nilai K, nilai K. Rate constant is given 1.7. Find the time in seconds. So you need to calculate T in seconds needed to decrease the 2 mole. Nah, dah tahu dah. Sekarang ni dah tahu initial concentration dia adalah 2 molar, bukan mol, mol per liter, molar, to 1.25 final molar of the NO2. Okay, sekarang ni kita nak tahu dia, kita kena tahu satu maklumat sebenarnya kat sini. The rate constant for the decomposition. Saya pun dah tak ingat kenapa dia boleh guna second order. Find the time in seconds need to decrease. Nanti saya tengok balik lah. Tapi I think the information ni tak cukup. Ya. Tapi ada satu correction yang saya nak betulkan lah. Kalau second order tu, ni second order. Ya. This one is integrated form of rate law, okay, expression for second order. Okay. And then if you have, kalau kita tengok dia punya reaction tadi ialah 2NO2 kan. Okay. Producing 2NO plus O2. Okay. A ni kena ada. Saya tak explain A. A ni adalah this one. So that's why you can see ada dua kat sini. Okay. Cuma saya tak ingat macam mana saya boleh dapat yang ni. Saya rasa maklumat ni tak lengkap. When we know this one, then we can use this equation. Kalau kita tak tahu order of reaction, kita tak tahu nak guna yang mana satu kan. Sebab ada yang kita dah belajar ada 3. For order 0, for order 1 and for order 2. Cuma kat sinilah saya nak expresskan if you have tu coefficient kena ada kat sinilah, kena tambah. All this while we do not discuss that. Okay? Soalan? Ada soalan? Because number 8, number 6, I think 7, 8, 9, or starting from number 6, we'll be giving you the final answer. Okay, ada soalan. Tengok unit rate of constant. Mungkin jugalah, betul kot. Yes, correct. Thank you, Lian Yung. Right. Based on the unit of the, betul. Sebab unit sini adalah unit order of 2. Okay. Kalau kita tengok yang soalan yang awal tu, mana tadi Sorry. Bukan awal sangat. This one. Okay. Based on the unit, we know that it is order 2. Betul lah tu. Thank you. Oh, ni dah masuk thermodynamic dah. Okay. So soalan macam mana dapat second order tadi? Dah clear kan? It's from the unit of the rate constant, nilai K yang ni. So from that unit we know that it is second order, and then we use this equation. Okay. So let's look what do we have more. Ini tak ada apa lah. Ini explanation saya 6A. Okay. 6A. For the reaction given to you, the rate equation is rate equal to 1.4 times 10 to the power of minus 10. Okay, again kita ada unit given to you kan. Unit pun dah menunjukkan dia adalah second order. Okay. So if 3 mole, okay, if 3 mole of NO2 is initially present in a sealed 2 liter vessel at 25 degrees, what is the half-life of the reaction? Okay, so based on the unit of K tadi, based on the unit of K, yang ni nilai K ada dalam soalan, we know that it is order of reaction 2. Okay, so order of reaction 2, the formula for T half is this. Okay, so again, please pay your attention on A. Okay, so A dia 2 based on the balance equation yang ada atas tu, nilai A dia 2. Okay, so K kita tahu, A naught we know if 3 mole of initial, so kita dah tahulah kita kena cari dia punya molar lah. Sebab tu saya cari molar dia dulu ya. Given at initial you have 3 mole and then the vessel is 2 liter. So you get the final molar 1.5. So when you put everything here, K dah tahu initial molar tahu yang ni. So you get the T half value. That's what the question asks, the T half value. So B, refer to part A, what concentration and how many grams of NO2 remain after 115 years. Okay. So yang ni kita kena guna formula ni. So formula ni pun kita tahu this is for second order reaction only ya. Integrated form for second order reaction. So what information that you need? NO2 after 115 years. So NO2 original sama 1.5 molar. Okay. Yang kita nak kira NO2 after 115 years. So K kita tahu, kita masukkan nilai T ya. T yang ini. Cuma kena careful about units ya. Kena convert lah. Kena convert lah ke second because the unit is all in second. Remember that it's second. So you have to convert. Yeah? That's the hard part lah. Yeah? Kemudian refer to part B. What concentration of nitrogen monoxide would have been produced during the same period of time? Ini kena tengok balance equation lah. Okay. Nitrogen monoxide. Okay, kita tengok mole dia sama lah. 2 mole of nitrogen dioxide will produce 2 mole of nitrogen monoxide. So it has 1:1 mole ratio. Okay, it has 1:1 mole ratio. So sama lah. Mole of nitrogen monoxide will represent the mole of nitrogen monoxide. Okay, so mole of initial. Ini kena kira dulu yang part B baru dapat part C. So mole of initial nitrogen monoxide tolak mole of nitrogen. Sorry, a mole of initial nitrogen dioxide tolak mole of nitrogen NO2 left. Kita kena kira lah. Ni molar, so kena kira mol. Okay. Mol asal NO2 dah tahu. Kena cari mol selepas 115 tahun. So bila kira-kira, okay, this is initial mole, final mole obtained from B, so you get the new mole. So mole NO2 sama dengan mole NO. So you can get that one. Okay. Tengok apa lagi. Number 7. Okay. So the following data were obtained from a study of decomposition of a sample. Dia suka lari-lari tak? Of hydrogen iodide on the surface of gold wire. Plot the data to find the order of reaction, the rate constant, and the rate equation. So now the table has given you time as well as the concentration of the reactant against time. Okay. So ini memang susah sikit lah. Tak adalah susah sangat. Cuma dia panggil identification using initial rates. So the first plot should be this one. Concentration of hydrogen iodide ada dalam table tu versus time. Time pun ada. Okay, dapat dah. Okay, the first plot macam tu. And then kita nak kena dapatkan table ni. Rate of reaction. Rate of reaction. Ni bateri saya dah nak habis dah ni. Rate of reaction from this graph. Okay, ini cara dia. Okay. So hydrogen iodide ni kita kena kira lah. Okay, pada concentration hydrogen iodide X katakan. Sebab saya tak plot saya nak ambil concentration hydrogen iodide X. So saya buat dia punya slope, dia punya tangent. Okay, so from the tangent tu saya boleh kira rate 1. Kemudian saya nak ambil concentration Y pula. Okay, Y. Kat sinilah. Okay, saya kira dia punya tangent. So dapat rate 2. So samalah sampai rate 3. Katalah. Okay, so now I get a new set of data. Concentration sama. Saya ambil daripada sinilah. Kemudian nilai rate. Initial rate. So what we should do next? Sebab soalan dia calculate concentration, plot the data and find the order of reaction dulu. Rate constant and rate equation. Kita dah buku apa ni dah? 10.55. Okay, sekarang ni daripada data yang baru, the new table, we need to plot another one which is log R versus log hydrogen iodide. Data yang baru, data yang ni. So, okay, so now if we plot log R versus log hydrogen iodide, you should get a straight line. Macam ni, you should get a straight line. So from the slope, kita akan dapat order of reaction. And okay, from the slope, you can get order of reaction. So dah dapat dah order. From the intercept, you get log K. K is the rate constant, kan? So now, from the slope, you get order of reaction. From the intercept, you get log K. So you can calculate K lah. Alright? So now, so the question asks about find the order of reaction. So dah dapat dah. Order of reaction dapat. The rate constant dah dapat. And the rate equation. So this is the final equation. Rate equal to K, concentration of hydrogen iodide with order of reaction. Semua maklumat ni kita dah masukkan. So masukkan dalam rate law expression tadi. Okay, so okay dah ya? Right. Okay, calculate concentration of hydrogen iodide in millimole at 600 seconds. Okay, right. Okay, sekarang ni sebab saya tak kira So when you identify B, you should know whether it is 1 or 2 kan? Order of 1, order of 2. So from that order, you should know which integrated equation that you need to use. Integrated for first order ke, integrated for second order ke. Kena tengoklah balik dalam nota Macam tadi kita guna integrated form for second order. So yang ni kena ikutlah jawapan apa yang dapat, B ni nilai apa, then you use the right formula. Masukkan je. Concentration iodide, hydrogen iodide and 600 second. Sebab disuruh kira bukan disuruh tengok daripada graf. Okay. Alright. Sebab masa dah diberi, so you need to put it in the formula. Okay, nombor 8 ada ke nombor 8? Why should increase the temperature in increase the initial? Okay, yang ni boleh bacalah. Why increase temperature? Okay, effect of the temperature. Why should one expect reaction in a gaseous state to be faster than the same reaction in solid state? So ini pun baca effect towards reaction lah kan. Temperature, apa lagi tadi? Nature of reactant, tu semua kena baca lah. Nombor 9, kita tengok, sempat tak lagi, okay, just 1 minute. The rearrangement of cyclopropane has been studied at various temperature. The following values for the specific rate constant have been determined. So, diberi ialah temperature and then nilai K. So, the question from the appropriate plot of this, determine the value of activation energy. Okay, you have to use the Arrhenius Equation. Bila energy je ialah Arrhenius Equation. So ini dia punya equation lah. Ini dia punya equation. So use the graph to estimate the value of K at 500 Kelvin. So you have to plot the graph. Ln K versus 1/T. Okay, mana dapat daripada sini lah. Okay. Value ada, T dah diberi, so you plot 1/T versus ln K. K dah diberi dalam table. Okay, use the graph to estimate the value of K at 500 Kelvin. Ini interpolate je lah. Okay, so 500 Kelvin, T dia sini 500 Kelvin, so kena kira dulu 1/T, and then from here dapatkanlah K berapa. Itu je. Tapi kena guna graph. Okay. Use the graph to estimate the temperature at which the value of K would be equal to 5 times 10 to the minus of 5 second. So, inilah pula terbalik lah. K dia tahu, kita interpolate, dapatkan nilai T. That's all. Okay, yang penting kena belajar plot graph. Kinetic banyak graph. Ataupun soalan yang ratio tadi, concentration effects, okay, kira dia punya order of reaction. Okay, nombor 10, nombor 11 ada dalam video. Ada dalam video. So please watch the video. So habis, so banyak electrochem, jawapan dah ada. So please study. Okay. So electrochem, jawapan dah ada, soalan dah ada, jawapan pun dah ada. Saya akan cuba share sekali walaupun dalam tutorial yang saya share tu pun dah ada semua jawapan dengan soalan untuk electrochem. Tak semua ada jawapan. So nucleus chemistry, saya akan bagi jawapan. Saya akan bagi jawapan. I think that's all. Kalau ada apa-apa, you all study dulu. If you need to talk to me, personally pun boleh. Saya ada je hari-hari yang saya datang ke UPM. So kena set appointment lah. Yeah. Alright.
Okay, Prof. Okay,
Alright. So thank you.
Prof.
Yeah.
Prof, ni kira last kelas ni ke, Prof?
Ya, betul.
Prof je tak gambar, Prof.
Alamak.
Alah, kenapa, Prof?
Hari ni tak boleh. Hari ni tak ready lah. Okay, boleh. Cuba sekejap. Ya, video ni saya akan share. Saya stop dulu ya, dia punya recording.